All right, we are in our AP Stats class, period 2. I didn't record this, so I apologize, but we just finished working on this problem between Domino's and Pizza Hut. And just a quick high-level summary. Obviously, the takeaway is to go eat Giordano's in Chicago. There's no reason not to. We define our parameters. We set up our hypotheses. Of course, why wouldn't there be a phone call? We checked our assumptions and conditions. Hello, Mr. Frederick. Sure, you got it. Thanks. Luis, you're being picked up. All right. We did our assumptions and conditions. We had a new assumption. Do we have a new assumption? Yes. Well, new, but also the same, right? We checked this one with 2 proportions. But we made sure they were independent. We made our statement. You guys drew the histograms, yes? For the nearly normal condition. By the way, we did our mechanics, all of our work here to find our t-value. How did we find the degrees of freedom of 32.76? We used the calculator, always the calculator for 2 sample t-tests. Do not try to do it with a formula. Use the calculator. And we drew our curve. It was a 2-sided, 2-tailed test. Since we used not equal to, our p-value was tiny, almost 0. So we concluded this. All right, see, I didn't need to record yesterday. That was just the same. So now the question is, if we think there's a difference in Domino's and Pizza Hut, and actually we're saying that we think Domino's has a higher fat content on average, I want to know how much higher. All right? So this is where we're going to use, I think you have a slide. Do you have another slide under there? Excellent. So we're going to do a 2-sample t interval here. 2-sample t interval. Okay, here's the formula for that. We have y bar Domino's minus y bar Pizza Hut plus or minus t star with 32.76 degrees of freedom times the standard error of y bar Domino's minus y bar Pizza Hut. All right, now, as I said in the past, the AP exam, the exam will give you the formula for the standard error of the difference of your 2 averages. All right, so this formula will be given to you. All right, so you don't have to memorize that. But as we've talked about in the past, when they give you confidence interval formulas, they only give you one, and it says statistic plus or minus critical value times standard deviation. So it's not specific, super generic, okay? Do you remember what this is called? Very good. It's called the margin of error. Whatever's after the plus or minus, all of this, when we multiply all that out, will be called the margin of error. Okay? So let's plug in the stuff we know. I believe you guys know the average fat content for Domino's. It was in the 11s, I think. 11 point, you might need to flip your page. 11.25 minus
6.53.
6.53. Please ask if you don't know where we're getting these. This is from our statistics on our test we did yesterday. Okay, let's go ahead and leave the t-star blank for now. We'll come back and write in that one. Times, and this is the square root. This actually is the same denominator you guys had for that t-value we calculated yesterday. All right, if you look back, I guess I can go back. Why don't I just go back and look? Do you see this denominator here? This is what we're going to copy. All right, so this right here is going to be our standard error. All right, so there's no change there. All right. So we have 3.19 squared. Okay, so it's 3.19 squared over 20 plus 2.59 squared over 15. Okay. And pause for a second.
You said yesterday you mentioned variance is sad. Is that why you said that?
That's why it's addition, yes. And remember the formula for 1, let me see, let's do a little quick aside here. Margot's brain would like to see it, so let's just show everyone. Do you guys remember the standard error for just 1 y bar? That formula. It's s over, not just n, but you're good, square root of n. So the idea is if we want to take 1 and add it to another, this is the standard error. So how do I find the variance? What do I do with this? No, what do I do to this to get the variance? You square it. So it's this squared, and you add another one. Oops. Sorry. And then they do algebra to make it look like this. So you'll notice the square root now is on the whole thing because they want to then, after they variances add, then they're going to do the square root of the whole thing. All right? And so they just clean it up a bit. They move the squares to the top, right? And what happens when you square the square root? What happens? They go away. So that's why there's no square root in those on those ends anymore. Is that? I don't know if that was helpful. What if I just took the phone and just threw it against the wall and it shattered into 1,000 pieces? Yeah, I said it. It's Mr. Frederick. If it's senior trip money, not chocolate money, it should go to Mrs. Platero or Miss Strick. Yes. Yeah, and just can you say like, does it go to Miss Platero? I think it goes to her, right? Yeah, Ruby. Perfect. Thank you. May 29th. May 29th. You can do this. May 29th. You got it. That's all I need. Just tell myself that. Okay. Everybody good? Sorry for the little sidebar there. I just figured, you might want to know where they got that from. That's how they do it. Okay? Okay. So now we need to find T star. So I'm going to do a quick little tiny T model. Nadia's already calculating it right now. No, you weren't? Oh.
I was just pressing buttons.
Well, you had me fooled. That's like when I don't know if you guys, since I'm much older than you, when you play video games as a kid and you didn't know what to do, you start like mashing all the buttons. Yeah? And be like, when you'd win, you'd be like, what? Awesome! Super Smash Brothers? Yeah. But only on Nintendo 64. That's the only one worth playing. Okay. You see, I drew a little T model up there. What alpha did we use yesterday? We used 0.1, and it was two-tailed. All right, which means 0.1 and two-tailed, you got to divvy it up. You got to divvy it up. So it's 5% here and 5% on this tail, which means how much is in the middle? 90. So if we're going to link this up perfectly, we should use a 90% confidence level. Now, would I be that disappointed if you use 95 or 99? No. It just would not be that perfect link between the tests we just ran. Okay? All right, so if we had used 0.05, like I thought we would use, then we would have used 2.5% here, 2.5% here, so we would be using 95%. All right, so that's the only difference depending on the alpha you choose. Not a big deal. Okay, so let's go to the calculator. All right, here's the Inspire. All right. And as I've said to you in the past, my only grievance with this calculator is the fact that when I run an interval with the t-test, that it does not give me T star. I don't. Do you want to head to the IT office and ask for AAA batteries? AAA. I think AAA? Yeah, that sounds right. Okay, if not, she'll come back. So, menu. Statistics. We're actually going to go to distributions. That's where we're going to go, to distributions. All right? Now, we need to find T star. That's called a critical value. So we're trying to find T. We don't know T, so we have to use inverse T. We want the calculator to give us T, so we're going to tell the calculator, here's the area under the curve to the left of it. All right? So I'm going to use inverse T. Now think back, look back at your, let's do right here, look back at your curve. Again, there's two options here. You can plug in to find the negative one or the positive one. It doesn't matter. What two options could I plug in where it says area? 5% or 95%. Now it's a decimal, right? I'll say it again. 5% or 95%. Those are the two options here. All right, to get the correct t-star. So I'm going to use 0.05. You could also type in 0.95. You'll just get the positive. I'm going to get the negative. Doesn't matter. I'm just going to write down the positive anyway. Degrees of freedom. 32 point, already forgot, 76? Excellent. 32, yes. 32, oh, you didn't get like a bunch of them? Just messing with you, John. You're good. 32.76, hit OK. And it's 1.693. But it doesn't need to be positive or negative because we're going to do plus or minus. 1.693. Now, can we pause for a second? I want to see if your brain can do this. What level of confidence are we using here? 90, right? What's the z-star for a 90% confidence level? No, that's for a 95. It'd be not 1.96. This is 1.645. Look at what we wrote. 1.693. It's fairly close. Why is it fairly close? Because the degrees of freedom is almost 33. So if that degrees of freedom became 50 or became 80, what's going to happen to this number? It's going to keep getting closer and closer to 1.645. Okay? All right, now, after I do this, where am I going to go? Because I'm not going to do any of this math by myself. Come on, that's craziness. So let's go to the calculator. Now, because I think I might have saved it, but just going to imagine I deleted all my stuff from yesterday. So when I do this interval, I'm going to use statistics. I'm going to use my statistics. If you still have your document from yesterday, you can use data. Right? There's two options when we do this, so I don't care. Pick one. So statistics. Now I'm going to run a confidence interval. Stat test yesterday. Confidence interval, number 6. Which one am I going to run? Number 4. 2 sample t interval. 2 sample t interval. Again, if you still have your data and you're in that document, you can use data. But if you're like me and it's gone or you're in a new document, then change that to be stats. So I'm using statistics. Hit OK. So now I'm thinking dominoes was my first one. I believe we wrote 11.25 for the average gram fat content. And then the standard deviation was 319. Thank you, 319. Sample size was 20. Pizza Hut was 6 point. Thank you. Standard deviation was 2.59. 20 or 15 of them? Okay. Confidence level, what confidence level am I using? 0.9. Pooling? No. Never. Very good. Right? Remember, PP. Pooling is for proportions. Bless you. Pooling is for proportions, not for our sample, P samples, T intervals. All right, you ready for OK? Okay. All right. Degrees of freedom changed a little bit. Do you see how the degrees of freedom changed? Why do you think it changed just ever so slightly? Because I used rounded statistics here. So it's okay. Don't worry about that. So we'll go with the margin of error is 1.655. So that's 1.655. Does it subtract for you? I'm sure it does, right? Yeah, the difference. You see this X bar difference, 4.72. Thank you for doing all the work for me. And then finally, my lower and upper numbers are 3.06 and 6.38. Okay. Okay. Now we're ready for what? Our statement. All right. Let's see what we got. I am %90 confident that the average saturated fat content in Domino's pizzas is between 3.06 grams and 6.38 grams higher than the average saturated fat content in Pizza Hut pizzas. Bless you. All right, now the key thing that I notice when I teach students how to do the intervals for the average difference is when you say your statement, when you write your statement, you want to talk about the averages, right? I see average, I see average. All right, so I'm looking for those things, those words. And I'm also looking for how much higher or lower, because it is a subtraction problem. So how much higher or how much lower? So if it had been negatives, if it had been negative numbers, then I could have written this two ways. I could have said Domino's is this much lower, or I could have said Pizza Hut is this much higher. Same with this one. I could have written that Pizza Hut is this much lower. Right? You can always do the reverse. I don't care. Whatever you like. Questions? On a 2-sample T interval. 2-sample T interval. Okay. So let's go ahead and stop this recording. Thanks for listening.